All right. All right, so good afternoon, everyone. My name is Bryant. I'm in the product planning and marketing team here at AMI. And as you can see from the title here, the theme of my presentation is how to empower your platform using open source or open system firmware, okay? So OSF for short. But before we address the how, let's talk about the why. I mean, why should we empower our platform? What does empowerment mean? Okay, and what's the benefit of it? So, if you are a platform owner and a cloud service provider, enterprise data center, telecommunications provider, one of the biggest challenges that you have today is how do you keep up with this constantly changing, increasingly complex compute ecosystem? I mean, if you look at the rapid growth of data and all of its processing needs, right, it's going to require massive scale of compute. The other challenge you have is your data center workloads are also becoming increasingly complex, right, which is putting performance pressure on your compute, which in turn is driving a proliferation of different compute devices with different architectures and different types. And then on top of that, your platform is going to have to contend or exist in a much greater threat landscape, okay? So this is where OSF really helps us. OSF describes or has a set of fundamental principles, if you will, or methodology that's going to help us navigate this landscape. The other thing that it's going to do, it's going to give you the ability and the power to control the firmware on your platform, which then in turn is going to give you the ability to make sure it's much more flexible and adaptive to that landscape. Okay, so it's with that context that let's dig in. All right, so OSF, okay, so that is an active working project group with an OCP with the mandate that it wants to transfer the platform ownership over to you, the system or the platform owner. So what that means is that it wants to transfer the point of control away from third-party firmware vendors like AMI over to you. Now once it does that, what does ownership mean? Well, ownership means that you own that platform all the way down to the source code. You're able to peer in your system to understand exactly what's going on. You're also able to understand the platform firmware, to change it, to modify it, to add specific capabilities to it as well. And then you're also able to respond much faster and quicker to any sort of firmware vulnerabilities and security threats. Okay, so how does OSF do this? Well, simply, it gives us 5 fundamental principles by which governs how you deliver open source firmware to your platform. So the first is that you need to be platform agnostic, right? So regardless if you're running on an ARM platform, an AMD, or an Intel platform, you want to make sure that your code can run on that. So what that means is that as you take code from an AMD system, for example, and port it to an ARM, you want it to have the same system behavior from a user experience, okay? So that means that the firmware has to be silicon agnostic. You got to be able to abstract the hardware layer from there such that you have a common core that you can then use across all of your platforms, okay? The next thing is that you need to be able to handle many different types of compute types. So CPU, GPU, DPU, IPUs, right? You're going to be in compute environments when all of these exist. So that means that your firmware is going to have to take greater control of those devices in order to make sure that they work much more seamlessly together. Security, okay, now this is a big deal, and we're going to talk about this in a little bit more detail, but essentially you need to make sure that the firmware on your platform can be trusted. You want to make sure that your platform is resilient. So that means that your firmware on your platform is going to have to be able to upgrade, downgrade, go through a much more thorough attestation, if you will. You also want to do attestation on your platform to make sure that you have the right combinations of firmware. Okay, so we talked about the ability to change your code. You also want to be able to share it. I mean, that's the whole point here of open source, right? That we build on the shoulders of others in the community. And then the last thing is you want to make sure that you have a robust set of development tools for development, for your build environment, and for open source distribution here, okay? You need to have this across the entire life cycle of your platform. Okay, so I talked about platform a lot, but I've not defined it, so let's talk about that. All right, so what is a platform? Well, a platform is a combination of your hardware and your firmware that's going to allow you to do three main things. Number one, it's going to allow you to power up your system. Number two, that's going to allow you to manage your platform across this entire life cycle. Number 3, it's going to enable it to run secure. Okay? Now, broadly speaking, there's 2 types of firmware that's on your platform. There is system level or foundational firmware, BIOS, BMC, hardware to trust, and then there's device level firmware, so your power supplies, RAID controllers, storage controllers, your NIC devices. Now, while OSF doesn't specifically give any guidance here, the most important thing to remember is that from a platform security standpoint, you still want to attest that firmware on that platform. You want to make sure that it's authentic to the manufacturer that's providing that device. Okay? Now, today, right, there are many big tech companies, many cloud service providers that are already doing this. They're already building platforms based on many of open source frameworks. And again, the main reason for that is they want to make sure that they have a flexible platform and one that's very adaptable to this changing landscape. Okay, so we talked a little bit about your data center workloads in terms of it becoming more complex, which in turn is going to drive proliferation of compute devices with different architectures. That in turn is also going to drive new system architectures, new platforms, architectures that are going to be more modular, composable, and decomposable. Okay. Now, 2 such solutions here are DC-MHS, so Data Center Modular Hardware System. Next one is DC-SCM, so Data Center Security Control Module. Okay, these are leading the way to creating a much more modular data center, and more specifically, a more modular firmware stack. Okay, so now as you build your system based upon these modular components, okay, how do you build the firmware to handle all the uniqueness and complexities here? In order to do this, in order to have your firmware be able to handle the different workload requirements, the different types of compute devices, you need a build orchestrator. Okay? A build orchestrator is going to take the specific CPU, its capabilities, and it's going to automatically generate and build your firmware image, okay, based on that compute type. So it's basically going to package up your OS payload, your platform orchestration layer, the hardware silicon enablement that you've chosen, in addition to any hardware abstraction layer. Okay. Now, I know I've glossed over that in a big way. If you want to learn more about that in detail, please come to this presentation at 4:30. Our CEO, Sanjoy Maity, is going to go through this in much more detail for you. Okay, so the next thing is, let's talk about optimization of your platform. Okay, so you need, as we said before, a robust build environment, development environment for tools, right, and source code distribution. When you're in development, you're going to go through many iteration cycles with the silicon provider, and you're going to have to triage whether it's a firmware defect or a silicon defect. Okay, so you need to be able to iterate fast and move quickly. When you operationalize it at the ODM or the CM to bring up their platform, you're going to have to make sure that you also have a set of common tools to enable them to do their own platform builds as well. And then lastly, from an SDLC standpoint, you want to make sure that you can easily upgrade your platform. You can also want to make sure that you provide security patches. Okay, now, when you're in the field, okay, the whole goal here is you want to make sure that your platform runs as efficiently as possible. So you need to collect as much telemetry data as possible. This could be around the CPU, power and thermal, GPU. You want to take this data, and then perhaps you want to run predictive analytics on it. Maybe you want to predict when you're going to have a memory failure. Again, the whole goal here is you want to make sure that your platform stays online and doesn't go down, so that way it's running as efficiently as possible. Okay, so let's talk more about your platform security, and specifically firmware security. Okay, firmware is privileged. It's got privileged access. So this means that any compromise to your firmware is going to be particularly insidious and have havoc over your whole system. Okay, now, just this year, the U.S. government issued a scathing report on the status of our nation's critical infrastructure, and they clearly called out firmware as an ever larger and growing attack surface. Okay, and there's 3 reasons for that. Number 1, firmware. Firmware is rarely, if ever, updated. That means if we have a day 1 or a day 0 event, you're already compromised. Okay. Number 2, Today, there's no automated way for your platform to tell if something has changed on it, okay? And it doesn't take it offline, so you then can validate whether that platform has been compromised. The third thing, or the third reason, is if you are a CISO responsible for software and security of your infrastructure, you have no idea what is the ingredients or components that make up your software. So you have no way to tell what vulnerabilities that may exist in your infrastructure, okay? So what can we do as an industry, okay? Well, there's several things that we should do. Number one, you should mandate, or we should make sure as a platform owner that we have a NIST-compliant hardware root of trust on our platform. And NIST adheres to a detect, protect, and recover methodology. So what this means essentially is that it's going to see if there's been any changes to your firmware on your platform. If it has, it's going to quarantine that, so that way you can then evaluate your platform. And then even better, it's going to recover to a known good state so that you can get back online as soon as possible. Now, I can't emphasize how important this is from a supply chain security perspective. You want to make sure that nothing is tampered with your firmware from the time it ships from the manufacturing site to the time it gets installed in the data center or your cloud environment, okay? Second thing is you want to make sure that you can remotely attest your platform. You want to take measurements on the TPM. You want to take measurements on the hardware root of trust from a foundational security perspective, okay? You also want to make sure that you can check on the combinations of firmware in your platform. When you validated your platform, you did so with a combination of different firmware versions, okay? So you want to attest it to make sure that nothing has changed on that, and then if it has, you have the ability to go back and evaluate that, okay? So the other thing is software bill of materials. So this is another executive order from the US government, stands for, and then this is called SBOM. So the idea here is that this is going to give the ability for you to understand ingredients and components that are in the software in your platform. It's a machine-readable file that's going to tell you the version number, the destination, origin, who's the author of that, what the update history has been on that. That's going to give you the transparency that you need to understand what software is in your platform, and more importantly, what the components are in that platform. Okay, so let's talk a little bit about OCP and the open source tree. So in March of last year, OCP mandated that any new OCP badge servers have to support OSF, okay? They did this for transparency reasons, reliability, security reasons, okay? So as such, at that time, AMI contributed our BIOS and our BMC code to OCP. Today, those platforms support Tioga Pass, Junction City, Awanda, and there's other platforms that we're supporting on EagleStream that we release. Now, this year, our whole focus and initiatives have been delivering an open source hardware root of trust solution. We wanted to complete the trifecta. We wanted to have a complete open source portfolio for foundational firmware, right, that we contributed to OCP, okay? Now, all of our open source trees for BIOS and BMC come from the Linux Foundation. We pull from OpenBMC, EDK2. We then take that, and then we create what's called a live tree. This live tree is what we do our development on. So here we're going to take our years of automated testing, and then we're going to address any security issues, any bug fixes, anything that finds, and we're going to contribute it back to OCP. Okay, now we then take that and we push out a release version to the OCP repository. This is where CSPs and data centers can take that and build on OCP-related hardware, okay? For every release, we validate it on the hardware that's in the repo. We do integrated BMC testing. If you find an issue here, we will support you. Any changes, we're committed to contributing that back to the upstream project as well. Okay, so how does this work in principle? Okay, so fundamentally, we have two cloud offerings. We have a community cloud offering that we host in OCP, and then we have a commercial cloud offering as well, okay? We have subscription packages for different capabilities depending on what your use case is. So everything on the left-hand side is really just visualizing what we just said before about OCP, okay? You can see we pull from Linux Foundation for EDK2 and OpenBMC. For hardware root of trust, we base that on the great work that Microsoft did on the Project Cerberus. We also had a partner that we worked very closely on to bring that product to fruition. Again, Sanjo is going to talk about that more in his presentation here at 4:30. Okay. Now, just to note, the hardware for OCP is going to be, for the hard route, will be on the next generation DC SEM servers that are going to come out. And then when those come out, you'll also see a complete platform that's going to have BIOS, BMC, and hardware root trust open source solutions on it. Now, if you need support for a non-OCP platform, if you need production support 5, 8, 10 years, you're likely to need a platform refresh. You more than likely need additional capabilities. You most certainly want additional security packages and fixes along the way. Okay. If that's what you need, then the commercial edition is what you should look at from AMI. Okay. Now, we have more advanced capabilities and services for the commercial edition. You can see here that we offer the firmware generator that we talked about. SBOM is going to be integrated or is integrated into our SDLC CI/CD pipeline, so whenever we release a firmware, the SBOM is going to come with it, of additional compliance testing and so forth, okay? So again, depending on what your need is and your requirement, we'll have a solution for you, and we'll be glad to work with you on that. Okay. 3 things I want you to remember or take from this. Number 1, if you decide to use OSF to build a platform, you don't have to use everything. You can go small. Just start with OpenBMC. Start there, build some success, and then you can decide whether you want to use the other platform firmware. If you also go with open source firmware, just remember you don't have to go it alone. You may want to work with a partner that's got really intimate knowledge with the supply chain, working with the ODM and partnering with the platform bring-ups. You may want to work with someone that's got a lot of experience in terms of porting code to the different compute ecosystem. Number 2, firmware. That's a soft underbelly of your platform, and you need to be proactive in protecting, okay? Now, to use or potentially use an overused marketing term here, zero trust starts with your firmware. It's like your basement door. You leave your basement door unlocked, you're vulnerable, okay? All right, and number 3, if you are a platform owner, please use a hardware root of trust, okay? This is only going to make your platform more resilient. If you are a consumer or user of a platform, please mandate that your infrastructure provider provide a hardware root of trust in addition to the software bill of materials, so you understand exactly what's going into your platform, okay? Okay, so with that, I thank you very much. If you want to see these technologies in action, or if you have any questions, please come see us at booth A14. Thank you.